Hunter Kanoki, and this is Fool's FAQ, a show where I take the internet's most burning questions and give you an answer that'll make you the smartest person at your next cryogenic chamber. On today's episode, the world's coldest retirement plan. Before getting started on today's episode, a quick favor. Rating and sharing this podcast is the best way to help it grow. If you learned something interesting or just want to share a little extra knowledge with friends or family, passing this episode or podcast along to even just one person means a lot. Thank you, and on to the show. Imagine this. You're dying of a disease that nobody's figured out how to cure yet. We're talking about something that's incurable today, but here's a pitch. What if I told you you could opt out of the whole dying thing and instead become a human popsicle? Literally frozen at minus 196 degrees Celsius. That's about minus 320 Fahrenheit. Stored in a giant tank of liquid nitrogen, just waiting. In the hope that someone in the future, maybe in 50 years, maybe in 200, doctors will thaw you out, cure whatever was ailing you, and boom, you're back to living your best life. It sounds like pure science fiction, right? But here's the kicker. Real people are actually doing this right now. There are facilities around the world, in the United States, Russia, Australia, and even Switzerland, that are currently storing hundreds of frozen human bodies, all banking on the idea that the future will figure out how to bring them back. It's called cryonics, and it's one of the most ambitious screw you death moves humanity has ever attempted. So, the big question everyone's asking, can this actually work? Can we really freeze humans and bring them back to life someday? So let's break down how cryonics actually works, because the technical side of this is wild. When someone signs up for cryonics, and yes, it's a real option, people literally pay for this, they have to arrange to be preserved immediately after they're legally declared dead. We're talking minutes here, minutes that matter, because the faster the preservation begins, the better your chances of whatever preservation entails. So here's the process. Right after death, technicians immediately begin what's called vitrification. Your blood gets drained all out, all of it, and gets replaced with a special chemical solution called a cryoprotectant. Think of it like antifreeze for humans. It's literally the same concept as the stuff you pour into your car's radiator to keep it from freezing in the winter. The cryoprotectant gradually replaces the water in your cells because, here's the thing, water is actually a huge problem when you're trying to freeze something. When water freezes normally, it forms ice crystals, and ice crystals are basically tiny knives that stab through cell walls and destroy everything. That's why if you've ever accidentally frozen a strawberry, it turns into mushy garbage when it thaws. So the cryoprotectant prevents that crystal formation. In the best case scenario, your cells don't freeze into solid ice at all. Instead, they transition into something called a vitrified state. That's when your body essentially becomes like glass. Frozen solid, but without the destructive ice crystals forming. Once that's done, your entire body gets cooled down gradually to around minus 202 degrees Fahrenheit on a bed of dry ice, and then, and this is the final move, you get placed into a large container called a dewar, which is then submerged in a massive tank of liquid nitrogen. You're now stored at minus 196 degrees Celsius indefinitely. You're the human equivalent of a frozen dinner, except nobody's planning to heat you up for decades, maybe centuries. Now here's where it gets interesting. Some of the earliest advocates for cryonics in the 1960s theorized that by freezing someone, you're essentially pausing the damage happening to their body. You're hitting the biological pause button, and if you pause the body at the moment of legal death before anything else degrades too much, then theoretically a sufficiently advanced future civilization could hit play again and reverse whatever was wrong. They could repair the damage caused by the disease, fix the freezing damage, maybe even genetically engineer you to be younger. I mean, it's a wild thought, really. It's the ultimate longevity hack. Just skip ahead to the future when medicine is better. The problem? Well, there are actually several problems, big ones. Here's the first nightmare. The cryoprotectants themselves are toxic. This is the cruel irony of cryonics. The very chemicals designed to keep your cells from being destroyed by ice crystals are themselves damaging your cells through chemical toxicity. Plus, to get those cryoprotectants to actually reach every single cell in your body, and we're talking trillions of cells, a lot of them deep in complex organs and especially deep in your brain, you need to perfuse them gradually through the bloodstream. That takes time and precision, and remember, in most cases, you're starting this process minutes or hours after someone's brain has been starved of oxygen. Your cells have already started dying. Your neurons are degrading. Then there's the ice crystal problem, which scientists are still fighting with. Even with the best cryoprotectant formulas, even with vitrification techniques, some ice crystals still form. And when they do, they cause what's called cryoinjury, damage from the freezing and thawing process. Now, this isn't just a small problem. When cells undergo freeze-thaw cycles, the damage is often irreversible. The ice crystals can rupture cell membranes, they can tear apart organelles, they can alter the physical structure of proteins, which is catastrophic because proteins are basically the machinery that makes life work. But let's now zoom in on the most critical issue, the brain. If we're going to bring someone back to life, we need their brain intact. Obviously, not just physically, but functionally. The entire theory behind cryonics is built on the assumption that if we preserve the structure of the brain well enough, if we keep the connections between all the brain cells called synapses intact, then theoretically a future civilization could map out all these connections, understand how they work, and rebuild a person's consciousness and memories. Now, here's the problem with that theory. We have no idea if it's actually true. And right now, we can't prove it, not even a little bit. Scientists have had some recent success with tiny mouse brain tissue samples. We're talking about smaller slices of a mouse hippocampus, not the whole human brain, and they've managed to vitrify them without ice damage using cryoprotectants. And when they warm them back up, the tissue showed electrical activity again, which is wild. But there's a massive gap between a tiny piece of mouse brain tissue can be frozen in thawed, and we can freeze a human person and bring them back to life as themselves. And here's another brutal reality. Even if future scientists could theoretically repair all the physical damage of your frozen brain, there's another layer of complexity nobody really talks about. During those hours or days between your death and your freezing, your brain undergoes serious biochemical changes. Your cells start dying from lack of oxygen. They're already damaged before the freezing even begins. And now that damage isn't just physical, it's biochemical. So even if future technology could map your brain connections perfectly and rebuild the physical structure, we don't know if the biological state of your neurons could be recoverable. And here's something else worth considering, the actual problem of revival. Now, freezing might be half the battle, but thawing and bringing someone back is, well, it's the hard part. And honestly, we're nowhere close to knowing how to do it. Revival would require not just thawing the body, but repairing damage from lack of oxygen, repairing damage from the cryoprotectant chemicals themselves, fixing the freezing damage, reversing the cause of death, and then somehow reintegrating everything so that person is functionally alive again. We're not talking about just getting a heartbeat back. We're talking about restoring consciousness, memories, personality, the full package. The companies offering cryonics are essentially asking people to have faith that science will advance so dramatically in the next century or two that what sounds impossible today will become routine tomorrow. And look, I'm not going to say it's impossible. In the 1950s, the idea that we could freeze human embryos and then thaw them out years later to create healthy babies would have sounded insane. And yet that's now a standard part of fertility treatment. So the historical precedent exists. But here's the catch. Embryos are simple, at least compared to the brain. They're a handful of cells, and a human brain has roughly 86 billion neurons, each connected to thousands of other neurons. Now, the complexity is astronomical, obviously, and unlike an embryo, which is designed by evolution to be able to pause and resume, a human brain that's been frozen and thawed isn't just pausing, it's experiencing trauma at a cellular level. So, here's the truth. We don't actually know if cryogenics will ever bring someone back from the dead. There's no credible scientific consensus that it will work. There's also no credible scientific consensus that it can't work, but that's a pretty important distinction. The technology required to bring someone back will be so far beyond what we have today that it's just hard to conceptualize. You're talking about nanotechnology that doesn't exist yet, molecular repair systems that we can barely theorize, and a fundamental understanding of consciousness and memory that we're still centuries away from achieving. So, can cryogenics actually bring you back from the dead? The short answer is we have no idea, and anyone who tells you they're certain either way is probably overselling their expertise. What we do know is that freezing a human body causes severe, irreversible damage at the cellular and molecular level using today's technology. Cryoprotectants are toxic. Ice crystals still form and destroy cells. Brains degrade the moment blood flow stops, and revival technology doesn't exist, not even in theory. We can't even bring back a fully frozen, vitrified mouse brain yet, let alone a human. But here's the thing about science. It's hard to predict what's going to be possible in 50 years, let alone 200 years. Maybe future technology will solve all these problems, and maybe I'll look silly talking about this in the early 21st century to someone listening in the year 4055. Maybe they've solved it, maybe they haven't. The people frozen in those tanks of liquid nitrogen are gambling on a future we can't predict, and honestly, that's kind of the ultimate leap of faith, freezing yourself and trusting that the future will catch up to your ambitions. So, the next time someone brings up cryonics at a dinner party or, hey, at a cryogenic revival convention, you can tell them it sounds like science fiction, and right now, it basically is. But never say never. Science has a funny way of making the impossible possible. Thank you so much for listening to Fool's FAQ. Feel free to leave a 5-star rating wherever you get your podcasts, as it also helps new listeners discover the show. For more fascinating answers to your burning questions, subscribe wherever you get your podcasts, and always stay curious.